be closed book, so you can't reference the textbook or your notes. However, I will put any formulas up on the board. So like some of the ratio stuff, like span to chord, that'll be up there. The gear ratio thing, that'll be up there. So you don't worry about memorizing any formulas. And that handout I gave, if you have any questions, come see me after class today. I'm going to try my very best to take some time at the end of class today to go over some of that worksheet. And if anyone has questions that the whole class can benefit from. So I'm going to try my very best to do that at the end of class today. So diving in, first of all, I think you did pretty good with making sure you have this big and scary book available to you. Did Ryan talk at all about this book yet? Ooh, I was the first one to introduce it to you. So this is sort of like the Bible of aircraft maintenance. I'm going to try to guide you through it in my classes because it has a ton of really good information, and the more you get used to it, the more it becomes your friend. Like right now, it's like, oh, it's so huge and scary. But there's a lot of super helpful stuff in there, and I'm going to be showing you some stuff as we come to it in class today, where it is kind of starting to get familiar with it. So today's goal is to go through algebra, just simple stuff, solving for one unknown, and then we're going to dive into geometry. So area, volume, surface area, and it may or may not involve some M&Ms. So speaking of algebra, this was me in high school. I think my book became very soggy from my tears, but now that I get to teach it and we keep it to the simple algebra, I actually do enjoy it. So in the textbook, page 3-16, it says algebra is the branch of mathematics that uses letters or symbols to represent variables and formulas and equations. So, I'm going to show you what that means. But instead of having odd numbers, we're adding in a letter that's unknown that we had to figure out. So now, I want to show you why it's important to be knowing how to do algebra. Because if you're like me, when I was in high school, I don't care. I don't want letters in that. They don't belong there. But it actually is helpful. So if you take your AC 4313 and just turn in the beginning after the very first page, and you see the table of contents, turn one page in. And that's just, you can reference that. The first chapter 1 you see is wood, turn a page, then it's fabric. So as we get to those classes, you're going to be going to those different chapters in this book. But we are going to go the whole way to chapter 4, and the page is 4-14. So, dive in. And if you look at the bottom of the page, on the outside of each page is a page number, and on the inside is paragraph number. So it can be confusing if you're looking here and you see paragraph 452, but it's actually page 4-12. So just kind of get used to how that's laid out. So on page 4-14, on the left-hand column, there is a formula. And it is a whole bunch of letters. It says setback equals K times the quantity of BR plus MP. What in the world is that? You don't have to worry about it until we get to sheet metal. But that is a formula. So you'll have to know how, and we're going to teach you in sheet metal what numbers go in there, but how to solve the numbers to get the answer. And so you know what you'll be getting into. It's calculating how much sheet metal you'll need to make a bend, because metal bends and stretches, and they have formulas for that. So that's one example of what you'll use a formula for. Then page 10-5, so going further back in the book. 10-5, now they have pretty little drawings, but we've got a whole bunch of more formulas. So we have CG equals D minus the quantity of F times L divided by W. Oh my. This has to do with weight and balance stuff. So if your aircraft is tail heavy and you need to shift weight, there's a formula for that. If you need to figure out what is the entire weight and where the aircraft balances, there's formulas for that. So again, you're going to be learning what goes where in weight and balance class, but in math, you're learning how to actually do the equation and work the problem no matter what numbers are in there. And then page 11-22, this is for Case, since he gets to have fun with electricity. 11-22, I don't know if you'll be doing this exact formula, but this is a good example. On the right-hand column, you got L equals a whole bunch of scary looking stuff. Ends up you just, multiply, divide, and you'll know how to do, well, you probably already know how to do that, but we will be refreshed on how to do that after today's class. And then 11-27, some other T2 equals T1 plus a quantity of TR minus T1 times a quantity of I2 divided by I max and the square root of that. But we're going to be working through that. And when you get to each of those classes, you'll learn, oh, this goes there, this goes there. Now you know how to solve it. So, step by step. This is just to show you that being able to do what I show you today is important, and you will be using that in lots of other classes. Yes?
Are we going to end up having to memorize any of these formulas?
No, which is the beauty of it. No, that was, because in high school and even college a little bit, I had to memorize, hated memorizing. I'm not good at memorizing. And when I got here, I was like, oh, they give you the formulas. All I have to do is solve it. Okay, that helps. So, continuing on with algebra, it gives you another lovely little example. I'm going to pull this up so I don't write on it by accident. At the bottom of page 3-16, gives you an example of an equation. Distance equals velocity times time. We're going to be working through that one in physics class, but you'll be given two of those letters. You'll be given number information, and you'll have to solve for one of them. Then at the top of the next paragraph, it says what an equation is. Algebraic equations are frequently used in aviation to show the relationship between two or more variables. So variables are the things that change. They vary. And an equation must have an equal sign. So something is going to equal something else. So we're going to be talking about area of a rectangle later today, but area, whatever that number will be, is going to equal the length times the width. And since it's an equation, this has to equal this. So as if length gets bigger, the area is going to get bigger. If width gets smaller, the total area is going to get smaller. So just always thinking whenever you have an equation, at the end, left So their first one is 3. They use the letter n for the unknown, equals 21. So we want to get n all by itself so we can figure out what it is. Otherwise, there's other stuff in there and it gets messy. So whatever you do to one side of the equation, you have to do it to the other side to keep it equal. And in this instance, since, what function is indicated here? Excellent. Multiplication, because they're right next to each other, a letter and a number, that means they're multiplied. So how will I get n by itself? How will I get rid of 3 to cancel out on the right side? Exactly. Divide it. So whatever function is happening, you just do the opposite and make sure you're doing it to both sides. So I'll indicate division like this and this. These cancel out nicely. And n equals 21 divided by 3, which is 7. And then, if you wanted to, you could come back to the original equation and say, does 3 times 7 equals 21? And indeed, it does. Next one is n plus 17 equals 59. Now, what do I need to do to get n by itself in this situation? Exactly, subtract it. So I got plus 17, so I do minus 17 equals 0. And I had to do the same thing on the other side, minus 17. So n equals 42, which is a very good number. And I could go back and say, does 42 plus 17 equal 59? To do what I call the sanity check, make sure it makes sense. Over here I have room. Next one is n minus 22 equals 100. What do I need to do to get n by itself this time? So add 22, and that equals 0. I must do it to the other side. And n equals what? 122. So then I have to go back. So 122 minus 22 equals 100, and it does. And then we have n over 5 equals 50. So what does that indicate? Division. Excellent. So what do I need to do to get n by itself? Multiply. So I'm going to indicate that by a little dot. So times 5 and 50 times 5, and n equals what? 250. So I could go back and say this 250 divided by 5 equals 50, and it does. So and this is, we're gonna get into equations, some more complicated equations, but that's the basic algebra stuff that you need to know. Just solving for one unknown. Whatever function is indicated, do the opposite, and always do it to both sides. Any questions on that? So I have a very, very fun thing to show you. And this is, maybe I shouldn't tell you. Case gave me the idea. He kind of mentioned it, and then I took off with it. So I said, oh yeah, I really like that. Because in the past, we've had people get to electricity where you have a lot of algebra, simple algebra, but involved in equations, and people get really mystified and confused when they're putting other letters in, and it's like, it's just a letter, you're just solving for it. So, I have this lovely wheel. Well, that might help if you could actually see it. There. So, don't let the letters worry you. Case is going to tell you all about them. If you want to know, P equals is the symbol for power. R, resistance, is a symbol for ohms. E is a symbol for volts. I is a symbol for amps. If that's all Greek to you, actually some of it is. Thank you. You're very gracious. Don't worry, you're going to learn about it in electricity class. However, you should be able to figure out these formulas using simple algebra. So, to start out, we have E equals I times R. So, I want to know what does R equal. That's really tiny. I'll make his legs longer. There we go. What would I do to get R by itself? I think I heard it.
Divide.
Yes. So divide. Yes. And I have to do the same thing over here. So this cancels out, and R equals E over I. And let's check if we are correct. Yay! R equals E over I. So you already figured that one out. Next one is, now, what does I equal?
I equal R divided
Wait. So we have to do, what do we have to do? Yes. And divide by R. So now, these cancel out, and I equals E over R. And if we're right, bam, I equals E over R. Now, looking at E, if E equals P over I, what does P equal? Yes.
E times
Multiply by I and multiply by I. P equals E times I. Beautiful. And while we're here, what does I equal? If we use this equation, it'll make it a little simpler. I equals, so we divide by E, and divide by E. I equals E over E. And I'm going to put also, yes, P equals E times I, and I equals P over E. Yes.
Is power the same as watts?
It's, well, I believe so. Check, okay. I had to think if that's always true. So then, next one is P equals I squared times R. So now we're throwing an exponent in there. So what will R equal? divided by I squared. And R equals P over I squared. I'm not square, I'm a people. Then we have P equals E squared over R. And I want to know what R equals. This one's a little trickier with a little extra stuff in there. So, if we want to get R by itself, what do we need to do? I think, I heard divide. By, yeah, divide by I squared. And I squared. So, R, I'm doing it, what am I doing?
You already did that.
P equals,
Yeah,
yes,
yeah.
I'm writing on the wrong one. I'm like, okay, I'm confused. Yes, I want P equals E squared over R. And we're looking for R. Okay, back on track. So, first of all, sorry, erase the last 2 minutes.
No, you multiply.
Try and find R.
Yes. So first of all, because R is on bottom, we'll multiply by R, because it's E divided by R, and P, I'll come over here, so it becomes P times R equals E squared. Yes. Now, yes, divide by P, and R equals E squared over P. Okay, since I confused everyone, yes.
So if you understand the process, can you just switch P and R?
Yes, but you have to understand the process of why you can do that. Yes. And I'll show you that one. R equals E squared over P. Now, we want to get E by itself. How are we going to do that? Yes. Bam. Bam. So if we go back to, yes, P equals E squared over R. And we want to get, our ultimate is E by itself. E equals, so E times P and R times P. So R times P equals E squared. Am I done?
No.
Correct. What do I have to do now?
E equal R times P divided by itself.
So E's over here by itself, so all I have to do is my little radical sign to indicate the square root of it. So E equals the square root of R times P. And there we go. E equals square root of R times or P times R. Yeah. And then the last one is back to P equals I squared times R. If I want to find I, what do I do?
Divided by R.
Yep. Divided by R. P divided by R. So, yes. P over R equals I squared. Oops. So then I have to do the square root. Square root, so I equals square root of can be given one, solve it, or switch it around. You're able to solve for any unknown, basically. And that will come in very handy in electricity class, because sometimes you'll have volts and ohms, or amps and power. You're going to be given different information different times, having to solve for a different unknown. So being able to work the formula, solve for any unknown, comes in very helpful. Any other questions? Okay. So then it says, it gives you another really interesting example. So those were solving for an unknown wherever it is. It might be in a really wacky place. Something that's a little, depends if you think it's easier or not, is another application on page 3-16 of algebra is to solve an equation for a given variable. So in this situation, your unknown is already by itself, but you have a whole bunch of equations stuck out on the right side. So they give this formula, which you will be doing in electricity class. All by itself. So it is C, total capacitance, and you'll learn what that is later, equals 1 over capacitance 1 plus 1 over capacitance 2 plus 1 over capacitance 3, and depending on your circuit, this could go on for a very, very long way. I'm going to stop right there. But it tells you what each one of these letters represents. So it tells you that C equals 1 over 1. So capacitance 1 is 0.1, and capacitance 2 is 0. Okay, I worked that right. 0.015, and capacitance 3 is 0.05. Now, how in the world would you start going about solving that crazy thing? What would you do first?
Divide each one.
Yes, exactly. So you start to simplify. So you can do 1 divided by 0.1, 1 divided by 0.015, 1 divided by 0.05. And if you had memorized that powers of 10 table, you could do that really easy, but I do not expect you to do that. So what is 1 divided by 0.1? Plus 1 divided by 1 divided by 0.015 equals
66.66.
plus 1 divided by 0.05.
In that case, would you normally round it up or not?
You would. I'm doing what the book has, so our answer turns out, but you are correct. When you are in cases of electricity class, always round it correctly. Thank you. Now, what am I going to do? Add these. So 10 plus 66.66 plus 20 equals 96. Hold on. Come over here. Total capacitance equals 1 over 96.66 convert it to a decimal. So, how would I convert this number to a decimal?
Divide the one.
Yeah, 1 divided by 96.66 equals 0.1034. So just doing it, writing everything in correctly to your formula, and then simplify, simplify, simplify. Any questions on how this formula works? Because we're going to add some rules to solving equations. So at okay, they talk about one thing and then they talk about rules. We're going to talk about it all together. So on page 3-17, it talks about use of parentheses. So groups of numbers, parentheses are used to group numbers or symbols together. Whenever you see parentheses, those functions are solved first.
Which page again?
3-7. 18. 18 in your books. Thank you. Thank you very much. It says use of parentheses is where I'm at. So sometimes, we're going to see this in the next one, you're going to have something in parentheses, like that, and then something in brackets, and then more stuff. So you always do the parentheses first, and then the brackets, and then the rest of the equation. We're going to talk about all the rules, and the way to remember the rules, if you learned this in high school, or maybe before that, is this acronym, because we love acronyms in aviation, haha, or maybe not, is this. Who has a good, or what you learned, yeah.
Please excuse my dear Aunt Sally.
Yes, that's what I learned. Please excuse my dear Aunt Sally. I don't know what Aunt Sally did. But when I came to SMAT, and then especially when I started teaching, I was like, I need something else. So here's mine. Pilots eat marshmallows during, hold on, I have it. What's my word? Aggravating situations. So you can imagine that, and that helps you. Pilots eating marshmallows during aggravating, or milkshakes, whichever you prefer. But what it means is, when you have a whole big, long equation, first of all, you solve whatever is in parentheses, and that also includes brackets. And then you do any exponent, so if you have whatever number with an exponent, and that also includes square roots, anything with a radical sign. And then multiplication and division. Multiplication and division, you always work from left to right. That was a very sorry arrow. Oh, that's even a sorrier arrow. Okay, there we go. Left to right. There we go. So, multiplication and division. And then addition and subtraction, again working left to right. So if you kind of memorize PEMDAS, or pilots eating marshmallows during aggravating situations, that'll help you remember order of operations. Yes?
So is that the absolutely correct way to do it? Because I've seen other people argue where multiplication and division are switched.
So, multiplication and division in left to right order. So
Okay.
as it comes. Yes. It really, like these two things are together and these two things are together. together.
So if you're
Working
reading
left
left
to
to
right.
right, and you have a division problem come first, you do that one?
Yes.
Got it.
Yep. So the equation they give, let's see, I often run out of room. I'm going to start over here. Okay. So n equals parentheses 62 minus 54 quantity squared plus 6 squared minus 4 plus 3 times bracket 8 plus parentheses 10 divided by 2 parentheses bracket plus square root of 25 plus parentheses 42 times 2 parentheses divided by 4. Oh, I'm gonna do it. Plus 3, 4. Yeah. Little buddy fit in there. Okay. So double check my work. 62 minus 54 squared plus 6 squared minus 4 plus 3 times 8 plus 10 divided by 2 plus square root of 25 plus 42 times 2 divided by 4 plus 3 fourths. Okay, that's like the most important step is making sure you write it down correctly or you'll just be wrong. So, going back to pilots eating marshmallows during aggressive situations, aggravating situations, what am I going to do first? Parentheses. So, and these I also do left to right. So I come over here and say, oh, here are my first parentheses. So, what is 62 minus 54? So, n equals 8. And I have to remember that is squared plus 6 squared minus 4 plus 3 times. Now we come to this whole thing. What do I do here? Parentheses first, so 10 divided by 2 is what? And now, since I solved that, I can go to my bracket, and what is 8 plus 5? So I can actually get rid of this. 13 plus square root of 25 plus, now I have another parenthesis, and what is 42 times 2? And divided by 4 plus 3 fourths. Okay, what's next? Exponents. So now I do all my little exponents and radical signs. So 8 squared is what? 64 plus 6 squared is 36. That looks almost like a multiply. Minus 4 plus 3 times 13 plus, what is a square root of 25? 5 plus 84 divided by 4 plus 3 fourths. So this is positive, so it would just be a positive 5.
Because you're dealing with positive numbers, not negative.
Correct. Yeah. Now, what is next? Multiply and divide left to right as I come to it. So technically this is indicating division. So you could take 3/4, and what is 3/4 as a decimal? 0.75. I'm going to do that because I like decimals better than fractions. Now, what am I going to do? Addition and subtraction from left to right. So this is where you can take your calculator and go 64 plus 36 minus 4 plus 39 plus 5 plus 21 plus 0.75, and finally we get n equals, what is our final answer? 161.75, or your books kept the 3/4. So, any questions on how to solve equations? You are going to have some lovely practice, but first go take a break and come back at 35.
Did you read it?
You're done with them for today. They do.
If he says no to you, I'm not gonna make an offer on it. I'm just gonna show him.
just put in the answer. And I'll talk through the paper one. But typically, if you're using a calculator, you just put it all in there and have the answer. The one thing, talk about this, if you do show me your work, you somehow mess something up and get the wrong answer. The more work you show, the more credit you get. Unless you mess up at the beginning. But if it's like that one last little, I don't know, you miss a decimal point or something. I mean, that's, your answer's still wrong, but you have the right idea. So, however confident you just know the answer. best use your calculator. In mine, I would put a parenthesis, 10 plus 8, parenthesis, divide by 2. Like that. So I'll let you work on that one for a couple minutes. Question 9. If anybody needs help figuring out your calculator, I'll be glad to try to help. Or if your neighbor has calculator experience. And I do have a spare scientific calculator if anybody is in desperate need. $25. No.
What? Actually, I don't know. It doesn't just sometimes.
Oh, part of it.
Yeah.
I'm down with that about
You're welcome to use the computer in the library if yours is spazzing out.
Yeah.
XPS 15.
It's a decent class.
It is. I do. I do. It's what?
mention again, I'm getting some good questions from y'all. Keep the questions coming. But guess what? I have another lab one. I'll hand this out and then I'll go over some of the specifics and then I'll give you some more time to keep working. Count. Beavers. I must have missed somebody. Uh-oh. There should be extra somewhere. Oh, hang on a sec. Oh, anybody have extra? Oh, no. Oh, no. Double check. I do. I'll print you out a copy. You're so generous. Did I? Uh-oh. Uh-oh. Okay. If you can look at your neighbors for instructions and then I will print you one. Okay. So if you go to the first page, it says complete the following questions. You may use a calculator, but show your work. So some of you are going to be able to just use a calculator, give the answer. However, the more work you show, if your answer is wrong, you do get credit for your work done correctly. So I would recommend for all these algebra problems, show me how you're getting the answer. So show me if you're dividing, if you're subtracting, show me that and then the answer. On question 9, that's a little bit confusing how it is written. Right. It should be 1/2 times W equals 20. And then 13, that should be -3/8 times T equals 12. So I didn't get time to go back in and edit it with a little equation fancy thing, so just know that. And then on the next page, solve for the unknowns. You kind of have to read through those word problems to figure out what they want and write your own equation. Let me know if you have any questions as you come to that. And then the last section is just those equations. Any questions now? Okay, I'll print out another copy. Oh, you got it? What?
I actually found it.
He wants to do double work? Okay, good. Oh, thank you. So, rounding. Go to thousandths place. Thank you very much.
So that would 15 just
entire answer that you get, or you can convert it to scientific notation. Not actually. Question 15. sorry, but I'm a little bit sorry. So, does anybody want to write down this information before I erase it? Or take a picture of it, make sure you have it for your lab. I don't want to need a picture. Leave no evidence of my presence. Okay. Going. It's going. And it's slowly gone.
Now we take a picture for erasing.
No! Okay. So we are going to move on into geometry. Woo. So first, in your book, it talks about computing area of two-dimensional solids. So that means something that is flat and it only has two dimensions. So first of all, they mention a rectangle, which we have right here. There you go. And it means the surface of the object, and it becomes measured in what is called square inches, because instead of just one linear line going on, we have two dimensions. So now if this was half a foot, then it is made up of 6 inches, but we also have inches this way. So we now have this way and this way, so we're working in square units, whether that's square feet or square inches or whatever it happens to be. So pay attention to these definitions of shapes. It might seem very elementary, but these are common oral questions. And when we get to trapezoid, I was asked that one on my oral. So this was general and airframe oral all together. So I had all the airframe stuff I was memorizing, getting all the oral answers in my head, and like sheet metal stuff and weight and balance stuff. And then in the middle of all that, he asks me, give me the definition of a trapezoid. And I was like, So he was very gracious and he let me draw it. So like, okay, I can do that, but describe, So if you're able to verbally describe it, that's good. Hopefully, I don't know if our examiner will still be here, whoever does your oral testing, hopefully they'll let you draw it out if you blank out like I did. But a rectangle is a 4-sided figure, and the opposite sides are equal lengths. So that side equals that side, this side equals that side, and they are parallel to each other. So like a good set of railroad tracks, they keep going on, and they'll never come together, no matter how long they keep going. And the formula, since you are now all experts at working formulas, for the area of a rectangle is length times width. That's all it is. And you will be given the length and the width. The example in the book is area equals, the length is, where did it go? 24 inches by 12 inches. All you do is multiply that and you have your area. I'm going to tell you, and I will repeat this, often you're going to see one of these given in inches and another one given in feet. So be careful that doesn't trip you up. Convert them all to the same. So whether you convert the inches to feet or the feet to inches, make sure your length and width are in the same units. A note on that. In your handbook, your little baby spiral bound handbook will totally disappear. Page 54 is It's page 54 in mine. Hopefully it's the same in yours. So, foot to inches. It's all right. 12 inches in a foot, 3 feet in a yard. And this is another place where it has statute miles, feet in a statute mile, and feet in a nautical mile. So some of this information is several different places. And then it also has a conversion to centimeters, meters, and kilometers. That's not very often that you'll need that, but know that it's there for you to use.
Which page?
54 in mine. Is that where it is in?
Yeah.
Excellent.
The 8th edition.
I don't even know what mine is. Oh, mine's 7th edition. Oh, I feel old now. Wait, did they? Oh, yeah. Okay, I'm distracted. So that is rectangle. There's your conversions. Next, it talks about a square. Now, a square is technically also a rectangle because this opposite sides are equal and parallel, but a square has another special thing about it. All the sides are of equal length. So, we could do area equals length times width. That would work. But we can make it even shorter because all the sides are the same. So we can do area equals side squared because we're working in square units. If you forget a square, you can just do length times width and you'll be just fine. But knowing that a square area equals side squared. Any questions on that? Okay. Next is triangles. We'll spend a little bit of time on this because triangles can be a little tricky. Haha, I did try that. Okay, you don't have to laugh. So, this is something else that could be on your oral. So what I recommend is mark it in your book. This is figure 3-16. And before you take your oral, come back, memorize this, and then you can go take your test, and then you can forget it forever and always. But so that you understand what they're talking about, first of all, triangle definition is a three-sided figure. The sum of all the angles, if you add them up, will always equal 180 degrees. So if I lay this out flat, it'll be a straight line. That's going to be a factor to remember when we get to the wee teeny tiny bit of trigonometry that we do. Very teeny tiny. Don't be alarmed. But triangle, all the angles always add up to 180 degrees. We have different types of triangles based either on their sides or on their angles. So based on sides, one name of a triangle is equilateral. You can remember it's equilateral because all of the sides are equal. So all the lengths are equal and all the angles are equal. An isosceles triangle, only two of the sides are equal. I'm not sure how you remember isosceles with two of the sides equal, but it looks more like an I than the others. Whatever you can remember it by is good. And then the scalene triangle, length of all sides are different. So if you think of scalene like a squirrel, because squirrels run all crazy, it's a very crazy triangle. None of the sides are equal. And then triangles based on angles. We have an acute triangle. Each angle is less than 90 degrees. And this goes way back to whenever I first learned about triangles. And acute triangle is cute because each little angle is small. So each angle is less than 90. Right angle has a right angle, and a right angle is always 90 degrees. So if your triangle has a 90-degree angle, that is also known as a right angle and a right triangle. Lastly is the obtuse triangle. One of the angles is greater than 90 degrees. How I remember it, it's opening up its mouth going, oh. I don't know if it's singing in the opera or if it's opening its mouth for some fried chicken. But has an angle greater than 90 degrees. Any questions on that, since I've now ruined your understanding of triangles? Okay. So the area of a triangle, again, so far, these formulas are always given to you. You don't have to memorize them. Definitely on all my tests and quizzes, I give you the formulas. And so far on the written exams, you are given the formulas. So hopefully that never changes. So formula for area of a triangle is 1/2 times the base times the height. Now be careful when you're given diagrams of triangles. They may try to trip you up at some point and give you, let's see, like this dimension here and say it's 34 inches or something. And also give you these pieces of information, but they'll throw in extra stuff in there. Make sure you're getting the base information and the height, which is from the base to the top of the triangle. A right triangle is very simple because the side that is next to the right angle is your height. But these other ones is a little odd, so you need the height, additional information to whatever the sides are. Any questions on that? And they give an example there. This is a tricky one. Ooh, I think I actually have it here. Look at that. So they give a triangle with a base of 3 feet 2 inches and a height of 2 feet 6 inches. So our formula is area equals 1/2 times base times height. So that means we need 1/2 times what is, here we go, 3 feet 2 inches. If we convert that all to inches, 38. So we've got 1/2 base, 38, plus, and what is, we do 2 feet 6 inches is 30 inches. And then we solve that equation just like normal, 38 plus 30, and times 1/2. So be careful again when you get mixed units, feet and inches.
It's not
Base.
added, it's multiplied.
Yeah, it's based
Is that what I said? Yes, thank you very much. See? I told you I make mistakes. And this is some of what I've seen in some of your work. It's super easy to make stuff like that. So I didn't do that on purpose. I could pretend I did. Thank you. And this is a good time to bring this up. So in math, do your own work. But when when you start to go out in the shop, have people double check your work. Getting a second set of eyes on stuff is really good because, or even if you don't have somebody else, back away, take a coffee break, water break, whatever, and then come back to your work with a fresh mind and you're going to see things like, oh, that was wrong. So thank you very much for pointing that out. And that's a good place for a break. Come back at 35. So it's Ryan's fault. It's not my fault that you have homework?
Yeah. Are we gonna have more? What are we gonna have for the rest of the day? Are we gonna have another?
A couple more. But we're actually moving along well. So I think we'll have time at the end to work on stuff.
Two or three? You said a couple.
I think, let me think. One, two, three would be the most. I don't think we'll get that far, so two or three.
mean, so for these two, I figure I put these in parentheses as
Yeah.
a place with the sum of that.
Exactly.
However, y minus 146, and then I divide it both sides. But that doesn't,
Y minus,
Might be wrong.
so y minus 146 and then b plus 1.
why is that?
Because this is the difference between, which means subtraction instead of division, or, yeah.
So it's essentially minus 146.
Yeah.
Okay,
Yeah.
alright, so, but if I do that, if I divide by minus 146, divide this side by,
So it would be, yeah, if you do 2 times
yeah, it's
40, and then, yeah, it's so y minus 146 will be and then get rid of that, add 146,
okay,
they'll cancel out, and then add 146.
okay.
8.2.
Could you do it like this, or not necessarily?
Sometimes it
Yeah.
works well. And sometimes it makes it worse, yeah, because it's considered not addable.
Is it because of the minus?
Right. It's not,
If you go to the.
negative 146, it's just
Minus 146.
subtracting.
Okay, okay. Alright, thank you.
You can't do that. You cannot do that. Turn it in. You cannot do that.
Like the
You cannot do that.
vibrations like go
I'm
through
about to
like
go
that
get mine.
and like
Mine, you go back to my old teacher. See if it's right.
like cause all the metal rods on here and things and
His
then
mom
vibrations like
used to be his
my mom.
last year.
Oh, wow.
No, like
He dresses in like orange robes.
First try.
as long as that fixes me, I'm good.
Oh, I was I got like a 63 and then came back, got like a 90, average out at an 80. But average is out.
Okay, we'll get started again. Oh, no.
He like asked me to spell.
Here. Okay, so if I can have your attention, back row. So what happened, as the year goes on and you all get more comfortable with each other, it's hard to like refocus after a break. So I have a can that what do I call it? Anyway, and I fill it with questions. And so if it's like the end of break time and I call your attention and there's still conversation, then you get to answer questions. I mean, I want to encourage conversation amongst yourself, but yeah, not during class. Anyway, so the next thing is parallelogram. So the definition is a four-sided figure with 2 pairs of parallel sides. So this is parallel to that, that's parallel to that, but there are not 90-degree angles here. Because in my mind, I think an elephant sat on it, but that won't work for a oral on right. Up. Eraser. There you are. Not length times width. It is length times height. And you have to come and make sure you are getting the height in not one of these sides. So the length times the height from top to bottom. And then we come to the trapezoid, which is, several people this past year got this as an oral question. What is a trapezoid? Again, hopefully you can draw it. But it has a four-sided figure with one pair of parallel sides, because other sides are wonky. And area for a trapezoid is 1/2 times base 1, so that would be here, plus base 2, and then you have to multiply in the height. So, what would you solve first in this equation? Yes, add the bases together, and then you could just go left to right, 1/2 times this answer times height. Any questions on those formulas? Next one is a circle. Ooh. So if I was a good teacher, I would have baked you all pie, because I talk about pie with circles, but I did not, so sorry. If you want to bake me pies, yeah. So a circle, the definition is a closed, curved, plane, meaning flat, figure. And every point on the circle is equal distance from the center. So it's not squished in any way. From the center, every point is equal. The diameter is the distance across the circle through the center. And the radius is 1/2 of the diameter. And the circumference is the whole way around the outside of the circle. The circumference formula is diameter times pi. Pi is, sometimes you can use 3.1415, is that right, I think? Anybody memorize out further than that? Impressive. You can use the pi function on your calculator, or if you like 3.14 is fine, but yeah, typically a pi function on your calculator. What pi represents is a ratio. Ooh, yay. Thank you. One thing you paid attention to now. The ratio of the length of the circumference to the diameter. So the circumference to diameter is what pi equals, and they do all kinds of cool stuff to figure that out. And that's always true. But through algebra, that's how we get what? Circumference equals diameter times pi, because pi equals circumference over diameter. So that's a little free tidbit for you. You do not have to memorize any of that. But then area of a circle is pi times radius squared. Pi r squared. Always wanted to bake a square pie, but I never have found a square pie dish. I'm sure they exist. Because pi r squared. No, pi r round. work through those formulas using the pi function times radius, making sure you square the radius. I do want to show you this now. So it says under circle, the example says the bore of a cylinder is 5 inches. We're going to talk about cylinders more in a little bit. But here is a cylinder from an aircraft. So this would be on your engine, something. Oh, bye-bye. Something like this. Excuse me. And your little piston goes inside your cylinder, and that's what's going up and down, and fire is happening, and then this is connected to a whole bunch of fancy stuff Ryan might already be talking about that makes your propeller go around. Anyway, the inside of the cylinder, from like straight across what would be the diameter, when you're talking about engines and cylinders, is called the bore. So that's just a term. You're going to be using it a whole lot. You're going to get used to it. But the bore is what is the diameter of a cylinder. Oh. Okay, stay. Don't fall on my toes. Thank you. So that, we'll talk more about it, but that's your introduction to diameter across a cylinder. Your book next talks about an ellipse, figure 3-21 is the formula. I've never seen that on any test, and that's really rare application in aviation. So if you want to work through that, more than welcome to. I'm not going to go over it. Yeah. But one thing your book does not mention, but is on ACS, is the word polygon. Where has polygon? I don't know. So polygon, simply, it comes from 2 Greek words. Poly means many. Gon means angle, so it just means many angles. Official definition, polygon is a closed 2-dimensional shape made of straight lines. So it's not a circle, not a loop, not an open loop. So here are polygons because they have straight sides, they have angles, they're closed. These are not polygons. So very simple and basic, just term to tuck away when you are in a testing situation. Any questions on polygons? Didn't know you'd be learning Greek today. So next we come to wing area. And we're going back to the terms that we talked about when we talked about span and chord and aspect ratio. So anyone remember what aspect ratio is? Exactly. So it is comparing our span from wingtip to our chord, which is from leading edge to trailing edge. And it just so happens that the area of a wing equals the span times the chord. This airplane is easy to visualize because it's basically a rectangle. So you're taking length times width. It just has fancy names, span and chord. Now, you probably already know, not all airplanes are created equal, and some have very abnormal wing shapes. Talked about this with aspect ratio. they can be tapered as well as swept back, or they can be nice, decent rectangles. When they are tapered towards the tip and the whole thing swept back, there is a formula that we will talk about in weight and balance, but for our purposes in this class, we'll just do average chord. So to get the average chord, if we measure this wing, and it was, let's say, 3 feet out here. Oops. Look. There we go. 3 feet across out there. And we did one here. And we got 8 feet. And then we did one here. And we got 6 feet. And then we went in the middle. And we got 5 feet. How would you get the average of those measurements? Yes.
Add them all up, divide them by however many you put in, which would be 4.
Exactly. So you just add all these together, and then that number you divide by however many measurements you took. So it would be 3 plus 5 plus 6 plus 8, which equals what? 22. And since we have 4 measurements, we divide 22. 22 divided by 4, and that equals 5.5. So that's our average chord. So we could go back in here, and if we knew the span, we would just do wingspan times 5.5.
Measure perpendicular to the fuselage?
Yes. So it's straight back from, now, there's more tricky stuff we'll talk about in weight and balance. But for our airplanes, when you go out to do a lab in just a few minutes, measure straight back parallel to the fuselage, leading edge and trailing edge. Because you run into some other weird stuff if you do angles. Again, this is not extremely accurate if you're actually doing aerodynamic stuff, but just to work with the math problems, getting a basic idea for area of a wing. Any other questions on that? So one note before I send you out to find wing areas is when we're talking about area, to not get confused when you're converting units. So a reminder, the area is in square units. So if this is 1 foot, that means we have 12 inches this way, 12 inches that way. So how many square inches would be in 1 square foot? 144. Because we have 1 square foot. So that means that we have to take 12 and square it. And 12 squared equals 144. That's very wonky. So if I have, let's say, 3 square feet, how would you find how many square inches that is?
36 square.
First, convert both numbers to inches.
You have to multiply it with your conversion factor twice. So you would multiply it times, if it's square feet, you want to go to square inch, you would multiply it times 12, and then by 12 again, because you're doing a square. If it was cubes, you would go 12 times 12
2 inches is 144 because it's 12 squares. So it would be 3 times 144 because there are 144 square inches in 1 square foot. So since we have 3 square foot, we're multiplying that by 144. Does that make sense?
Oh, it's not.
Right. Looking closely at what it is. If it was just 3 feet in a straight line, you would just multiply that by 12. But now that we have 2 dimensions, we have length and height or width or whatever it is. Now you have to account for all these wee little squares and take the square feet multiplied by square inches, which is 144. So that's, if you want to write that down, that'll come in handy on your lab, making sure you're converting correctly. Any other questions? Okay. Oh, it talks about square yards. 3 feet are in a yard, so square feet would be 9. I've never seen that. It's always feet and inches in aviation. So your lab, oh yeah, it's going to be on Moodle. Okay, this is a 1-week class. We're pushing through, so hopefully we're gonna have time Friday and tomorrow as well. So, oh, you can't see anything.
So how many weeks of math are we showing? Or do I not?
You don't wanna know.
That makes me feel better.
You don't
Wait,
wanna
so
know.
you said that this is the only week of math, though, right?
Yeah.
So
So
what's next week gonna be?
So next week is aircraft drawings, which is a little lighter, little lesson thing.
Oh, I don't like drawing.
And then the following week is physics, which is another more
You gotta know what now and Josh.
intense class.
This is unfair advantage.
So, go to lab 10. And I'm going to tell you some important information on this one. So it says complete the following questions regarding wing area. Number 1 should be pretty straightforward. How many square feet on a wing that's 32 feet 6 inches long, so make sure you're converting, and 20 inches wide. So whether you convert, I think this one I manually grade, yes.
Fuselage included into the wingspan?
So in these, it is, yeah.
Is that always the case?
For my math class, for any testing in math, it is.
Okay.
When you get into actual engineering, there's some people say fuselage is part of it, some people say it is. There's like a really big argument out there about it. But for FAA testing and classroom purposes, we'll include the fuselage.
Because when we had the one wing, we started at the fuselage.
Correct, yes, yes. But this one, and it does help, it gives you the whole line.
Yeah.
So, yeah, if we're doing something tricky, we would let you know. So that one should be straightforward.
Do we need to show our work? Text block instead of.
No. Again, the more work you show, the more credit you might get if you get anything wrong. But you can just put the answer in there, and I'm okay with that. Number 2, you'll need to get the average of 9, 7, 5, and 3 feet. And make sure you convert 45 feet, like the 7 inches into feet is what I would recommend. Number 3 is tricky. So if you did span times chord, they're only giving you this whole length. They're not giving you the average chord. So this you need to do leader. But that'd be helpful if you all have either a paper, or I'm fine if you're gonna record this information on your phone. You will need the N number of the aircraft. If you don't know what that is, ask NRI, because she'll be helping us when we're out there, and we will show that to you. And then the make and the model. Again, if you don't know what that is, we will let you know when we're out there. Then you're going to be measuring the total wingspan, so wingtip to wingtip, that'll be one number, and the average wing chord. So you'll take, it depends on the aircraft. The Cherokee is pretty simple. Some of the others, you'll have to take a measurement at the wing tip, measurement at the wing root, and then somewhere in between. Again, this is rough estimates. I'm more concerned about you doing the math rather than a super accurate measurement. Once you have the span and average chord, we'll come back into the classroom, and I'll give you some time to figure out the wing area. So you're gonna do a low wing aircraft, or question number 5, same information but on a high wing aircraft. So I'm gonna split you up into 6 groups. 3 will be on a low wing, 3 will be on a high wing. Get those measurements, and then we'll swap, and you'll be on the opposite of whatever you were. Any questions? Okay, I'm going to number you off. Stay in here, because once everybody gets a number, I'm going to have you gather into your groups in the classroom and make sure we have a group leader for each group, and then we'll go out. Other years has become very chaotic, so we're going to try to minimize the chaos. So, to make sure I'm on the right track, 6 groups, that means I'm counting off in 6s. So, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, not paying attention. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Hey, it worked out. So, if all the 1s could go in that corner.
You're banished.
And all the 2s in that corner. All the 3s at the back.
This corner?
All the 4s in that corner. 5s along that wall. 6s up in this corner.
Number 2 in this corner or this corner?
2s are that.
Oh,
corner.
yeah. You're gonna find the average chord, right?
As you gather in your groups, figure out who can be the group leader.
You guys are 6s?
6.
Sweet. If you don't figure out your group leader when I come around, I'll just assign one. Okay, so 1, 2s. Uh-oh, 3s and 4s are close. 5 and 6. So you should have, you should have 5 people in your group. Okay. Okay, you guys are all 1. Do you have a group leader? Group leader? So, if I could have everybody's attention, please. Once you get a group leader, your group leader will need to make sure you get a measuring tape and have either the group leader, or he can assign someone, to record the information that's required. So that's group leader responsibilities. Measuring tape, look at that. And make sure someone records. So 1's got settled. Are you all 2s? And who's your group leader? think we have another measuring tape up here,
Got two up here.
so if you can pass one to them.
Is that an extra one? Yeah.
Are you all three? And who's your group leader? I think there's one more measuring tape up there. You're all four.
It's gone.
Sweet. Group leader.
I was coming.
Whoa, who are you pointing at? Oh, oh,
So we're using it right now.
there.
I know, it's all.
So, measuring tape.
Exactly.
Well, I thought it was like,
Fill that sucker up.
You're all five. And sweet. So I will show you as well where measuring tape are. All sixes. Who's
get a bigger box.
I already have it like that. Let's prepare. Okay, so make sure you have your safety glasses because we are going out through the lab. And then I need to assign you aircraft. Okay, so group one, you are on the Cherokee first. Group two, you are on the Apache first. Group three, you're on the Bonanza. Group four, you are on the Cessna 172. Group five, on the Cessna 210. Group six, on the Cessna 182. If you don't know what airplane you've been assigned, just ask us when we go out. And before you go, when you flip-flop, group one, your second aircraft will be, wait a minute, what did I do here? Oh yeah. Your second aircraft will be the 172. Group two, your second aircraft will be the 210. Group three, your second aircraft will be the 182. Group four, second aircraft Cherokee. Group five, second aircraft Apache. Group six, second aircraft Bonanza. Any questions? Okay, make sure you have your safety glasses. And I will show these three, where measuring tapes are. So we are going to go the whole way out, through the hangar, outside. Grab a writing utensil.
you,
Just making sure, right?
after I add this, do I take 2/4 plus
So that, since you're right next to each other, that one will be multiplied.
or multiply?
So
Okay.
2/4 times
Okay.
that. All right, it is 35. So 1, 2, 3, 4 people missing.
I think that might be.
Oh, they might. Oh, there they come. All right, we're gonna cover a little bit more material. We'll see how far we get. Let's see.
Yeah, so maybe successful person makes the error, or the model that they
Yeah.
Are we just turning in the information for the graph that we did
still have
in
this.
the Moodle?
So you have 2 spots in this one.
I think I just have one. Four and five.
The second one.
Oh, okay.
There should be, yeah, 4 for the whichever.
Oh, I did the high.
Did you get the tail number?
So on that lab, make sure you're filling in information for the aircraft, and the one specifies your high wing aircraft, and the other one specifies your low wing aircraft. And also, I think I wasn't clear in explaining for span to go wingtip to wingtip, plus some of you had shorter tape measures. So if you did leave out the fuselage, just note that in the lab, write that in with your answer. Say, this was calculated without the fuselage. That's okay. I will, if you put that in there, I'll know that and grade it with full credit if you get it right. Yeah, let's move ahead a little bit with volume. So we talked about surface area, which is just a 2-dimensional shape, length and width. If we're moving from feet to inches, realize we have inches squared, so we got this whole thing full of inches. Now, we're adding on another dimension. There we go. And we've got volume. Let me keep better track of my poor little eraser. So in the book, it says computing volume of a 3-dimensional solid. So 3-dimensional solids have length, width, and height. So you can see the perspective on this. We've got length and height, and now we're adding in width. So this is a whole object like the cylinder here that has, it rattles, how curious. Has 3 dimensions, and you can fill it up with something. It has volume. Now, something to note on this, since we're going this way and that way, what sort of units are we working with? Cubic units. So, if I am going to take inches, or if I am measuring in feet, and I need to convert to inches, knowing that 12 inches are in a foot, what will my conversion factor be? Yes, 12 cubed, which is 1,728. So just keep that in mind that if you're converting feet and inches, it's after you get the final answer and it's in cubic inches or cubic feet, to use 12 cubed, 1,728. So if I have 3 cubic feet, like if this was whatever, yeah, feet cubic that is, to convert it to inches will be times 1,728 to account for all of the inches that fill up that entire cubic space. Any questions on just conversion from feet to inches with cubic stuff? Okay. So, talks about a rectangular solid, like this here, is a 3-dimensional solid with 6 rectangular shaped sides. So if you look, I'll use this book as an example. We've got this side here, that side there, and then it's got volume because it's all full up of pages. So volume of a rectangular solid is length times width times, now we're adding in our third dimension, length times width times height. So you just make sure you get all that information, that measurement plus that measurement plus that measurement, and just multiply them together. But remember, your final answer will be in cubic inches. And then, yes, I do have a cube. So a cube, as opposed to a rectangular solid, has 6 square sides. So all of these are equal to each other. So what can we do? We could do length times width times height. That would work just fine. But what can we do, like we did for a square for surface area?
That's cubed.
Yes. So volume can just be S cubed. And you can hit that little cube on your calculator and get the answer. The example they give for a rectangular baggage compartment above that, that's just multiplying length, width, and height. But make sure you're converting everything to either feet or inches. And it works a little easier if you convert everything before you multiply it, because then it's just linear, straight line measurements. You don't have to worry about the cubic units. And you will be doing a lab. I'm going to save it for tomorrow when we can do it today.
Thank you.
You're going to measure baggage area. And this is actually a practical thing, especially if you fly, to do. I had to do it when I took, I think I mentioned this maybe the first day, boxes. Had to know before I flew out to Pennsylvania that it actually fit in my baggage compartment. Boxes are easy to work with because you can measure, but maybe a little easier, we took some winter clothing and flew it to a mission up in the Upper Peninsula. The 206 has this cargo pod, so that way you can measure that volume. But if you have garbage bags full of clothes, you can just squish them in. So that's kind of, you just squish to weigh them so you know your weight, and then just squish till they fit. There are, so on 172, it's so nice, pretty much rectangular solid. Some stuff you're going to find on the one baggage compartment on the 414. Those compartments are a little odd because sometimes they'll have the divider in the middle and then it comes out straight, but then this side is curved, so you have to do some, where you won't make you measure that. You can just observe it, do some weird calculations with that because you have a curved side. But general estimates, and then see what you can stuff in it. Any questions multiplying it by the height. Again, you don't need to memorize these. The formulas will be given to you. Now, where this becomes very practical is with cylinders. So you are going to be asked to find the volume of a cylinder because that matters, because it matters how big your cylinder is, how big your whole volume of all the cylinders of your engine is, and then you can figure out some power stuff, which people tend to like. So, I don't like that one. This here. So you're going to be asked, we're going to work through this tomorrow, I'm just introducing it today, to find what is called piston displacement. So piston displacement is not the entire volume of the cylinder, because I really like Bold Method's simple illustrations. In the whole movement of that piston within a cylinder, it stops right there. So we have this gap up here where it is not moving through. So the volume of air that is actually getting pushed out is, right about there. So to find the piston displacement, because this is a cylinder, and we are working with a circle, we do have pi times, there's that term, the bore, which is the diameter across the circle. Bore divided by 2 squared, because why do we divide the bore by 2?
Get the radius.
Exactly. We just want the area of that circle. So pi would be pi times the radius squared, but typically in your engine information they only give you the bore. They don't give you half of the bore. So you have to take that information and divide it by 2, and then because the radius is squared, square it, and then times the stroke. Because if you took the whole height of the cylinder, that's going to get you the total volume, but you only want the amount of air that is actually pushed out. And that is information they give you in your engine information. They tell you the stroke of the cylinder, or how far it moves in one rotation of the crankshaft. And then, so we would stop right there, pi times radius, which is bore divided by 2 squared, times the stroke. That would give you the piston displacement for one piston. But most of our airplanes don't have a piston. So they like to know the piston displacement for the entire engine. So you just take that number and multiply it by however many cylinders you have. And a curious little free note on engines is they are, make sure I didn't miss anything important. Yes. So both of these engines have a displacement of 360 cubic inches. And that's how we often name engines. Like this is an injected, fuel injected, and a hose. You're going to learn all about that in Ryan's reciprocating engine class. And then the displacement is 360 cubic inches, so we call it either 360. However, 2 of the biggest engine manufacturers, one is Continental, the other is Lycoming. We'll learn all about that later. But do you notice anything, it's a little hard to see, different about the number of, never mind, cylinders on the 2 engines? Of course you do. So this one only has 4 cylinders. This one has, it's a little hard to see, but 1, 2, 3, 4, 5, 6 cylinders. So they both cylinders possibly, with the same total cubic inch displacement. Any questions on that? We'll work through the formula tomorrow. Yeah.
So which one has more power? Or are they have the same?
I don't know. That's a Ryan fact. He has like all engines memorized, like everything about them. In your book, I'm not sure what page it is in yours, there is figure 3-23, has conversion factors. You can use that as a reference as needed for your labs. It talks about volume of a sphere. We're not going to go through that. I've never seen that being tested. As well as volume, bless you, of a cone. Again, I've never seen that. If you get that on a test, please let me know and I will teach it next year. But there's no purpose I've ever seen in aviation for volume of a cone. And then it talks about units of volume. We already mentioned that it's cubic units, so you're using 12 cubed, which if you go back over to figure 3-23, it does say 1 cubic foot contains 1,728 cubic inches. And it also gives you the helpful information that 1 cubic foot will contain 7.5 gallons. Again, don't need to memorize that, but if you ever ask a question, you can come there and say, oh yeah, put 7.5 gallons into that. Should I save that for your lab? Or should I do it now? I think I'll do it now. I think you need it now. So, I can do it again tomorrow.
Okay.
I've seen this as a common problem, and so I'm trying to simplify it, because it is simple, but a lot of y'all overthink things. So, this is a surface area demonstration, so disregard for today. But, if I have a cylinder here that has volume, and it does happen to be full of M&Ms, so you can't eat them all now because I'll eat them. But if in 1 cubic inch I have 10 M&Ms, how many M&Ms will I have in 10 cubic inches? Yes. So you did perfect. When you get to the lab tomorrow, it's going to say you have however many cubic feet, and 7.5 gallons of fuel can fit into that 1 cubic foot. How many gallons will fit into 10 cubic feet? I've had people before divide instead of multiply. So, just if the M&M illustration helps you, if anybody wants some. You can pass it around. I'll add more tomorrow, but I went to school for it.
You can do that every day if you really want. I tend to forget sometimes.
Okay, again, we'll go over some of this piston stuff tomorrow. So if any of that is confusing, I'll talk about it again. Any other questions on what we covered today with surface area and volume? Okay. I'll take a few minutes and look at the quiz for tomorrow. So, first of all, if you have a little review sheet that I handed out, you can pull that up. Are there any questions that you have that I should focus on first? Because we won't get through all of the material. talking when you were reviewing it, you're like, I don't really understand that very well right now. So looking at your homework overall, you're all doing really good. I don't have really any concerns with this stuff. The one that we did not spend a lot of time on, that could be a little tricky, is converting a decimal to a fraction when you have a weird decimal. So if you have something like 0.312 how would you go? I'm very impressed. You're very generous with each other. Just finish them up. Unless you don't like them.
We're just passing this item and keep going.
So, how would I convert this decimal to a fraction? Yeah.
You convert it to a percentage first, and then fraction the answer.
The percentage wouldn't really help you in this situation.
How many places is the smallest and put it over whatever that is?
Exactly. So you count your decimal places to the right, put it over that number. So, what place is this? Tens.
10,000.
Beautiful. So we got 10,000. So we're gonna put 3, 1, 2, 5 over 10,000. Okay, that's a crazy, scary big number. And yes, I do want you to reduce it. So, what are some ways you could go about reducing that to a much smaller fraction? So you could divide by 25.
120.
Or you can go big and say, I think I could divide this by 125. I'm pretty sure 10,000 is divisible by 125. It's sort of a trial and error, but you can take your calculator and go 3,000.
Doesn't work. No room.
125 divided by 125, and what do you get? You get 25. And then 10,000 divided by 125 is 80. Can I make that smaller?
516.
And how'd you do that?
By putting it into calculator.
Which is allowed.
Number didn't work.
If your
Smaller one.
if your calculator will reduce it, that's totally fine. But
Yeah,
what
that could have helped.
could you divide this? Yes.
Yeah.
So I can divide 25 by 5, and that is, and I can divide 80 by 5, and that is 16. So that's kind of how you break it down if you don't have a smart calculator like Leo. Question?
It's probably not related, but yesterday, what were we doing with like the diameter multiplied by like 64 or whatever?
Yes. Yes.
I thought that's what we were getting ready to do with them.
Right.
I understood
So-
it's different, but
So on the quiz, you'll have something like this, and it'll ask you just to turn it into a fraction in lowest terms. But if you have, let's say, rivets, and your rivet comes in 30/2 of an inch, and you measure it, and it is, I'm going to throw a number up here so we're going to see if this works, 0.1673. But you want it as a fraction, and you want 32 to be your denominator. What you can do is take 0.1673, multiply by 32, and that answer becomes your numerator. Now, this is like 5.35, so you round it because you can't get a rivet in a decimal. So it would be
Round to the nearest whole.
5/32. Yeah. And you can go back and say 5 divided by 32 is 0.1562. So it's not exact, but when you're buying rivets, it's not going to be exact. You're going to have a little bit of one way or the other. So that is the method for like rivets or drill bits or something that you have to get a whole number. And this is a more exact method. Thank you. Good question. Yeah.
With the rivet, do you just round to the nearest, or do you round up or down? Or?
Round appropriately. So if it's,
It's 5.5,
yes, if, correct, 5.5, you would go to 6.
so that would be 6/32.
Now, practically, we're going to talk about some situations you want to be on the small side of your rivet. Some situations you want to be on the big side of your rivet. But mathematically, just if it's 5 or greater, round up. Less than 5, keep the number. Any other questions on that? Okay. I am not going to go through anything else with everybody. I'm going to let the rest of the time, you can work on your lab if you want to go through this worksheet. And any individual questions you have, I'll be very glad to answer those.
Do you like your roll back or should I keep it?
Oh, we have our, those look cool.
Whoa! Look at that.
On the math book.
So,
What were these things that we did yesterday?
Oh.
The one lab that we just did?
thanks.
Where was this? Yeah, it's like pretty big. What were the things for today? 'Cause I'm like remembering
Yes.
the other lab. So the only thing that we did, I think I did everything for math, but
So it'll be 2 lab 10. So 10 is
and the algebraic operations, we did that one on paper, right?
correct. 10 is assigned
So
to you.
our assignments on paper and then the quizzes are the ones that are like on Google. So like how do you?
Yeah. So your paper ones, I put those grades into Moodle so you see those grades. And then yeah, the labs are on Moodle. So if I can have your attention, maybe one more time. So Barb has your really cool, snazzy student ID card.
I can throw my one from like 7th grade.
And she's gonna make it really pretty and laminated. However, you need to sign them before she does that.
Oh, no.
So I have a pen, but if you have a special pen, you can use that. And she also did amazing Barb style and has them in alphabetical order. So if you can just come up in order. So David. You're signing for me to buy a Learjet. That's your student ID.
What did everything from that? Now it's back to the man.
First to last, I suppose.
Yeah.
Since I'm done with all my math today, could I go and do my other lab?
Can.
I'm gonna use, can I use the computer?
Yeah.
I don't think I'm bad.
Not too many at a time or I'll get confused.
Yeah.
Isaac. Pascal. And if you just sign underneath. Josh.
So quiz tomorrow, like first thing?
Yes, it will be. Then you can do all the information, and then on to news. I'll bet.
And final on Friday?
Final one. This is a class where you just hang on for dear life.
For a week.
Just a week.
No, we tried to like that.
And then Barb will laminate it and then give it back to you. So you can just.
Christina, I got my algebra paper. You want it in the box or?
Here's fine. Thanks. Austin.
I think that's what's, it's just huge. You can't really compare it to any square footage that would.
So you got the same answer?
Yeah. So you, but you did it the same way as I did, I think, where you just converted it into feet the whole time?
Yeah. Answer?
And Parker.
Well, we could just be wrong together.
Could be.
Just fine. And then Barb will laminate it and then give it back.
Technically, it was six to both sides.
Leo. Person.
You accept, just FT2 in front of it as P squared?
Yeah.
Two?
Yeah. I'm just fine. That one. See, now I can look at your face for that.
Do you want these here and now or in your box?
That's fine. Well, look at you. And then Tim Peterson. Uh-oh. You're not paying attention. Mr. Peterson. Uh-oh. Oh, did you just take my pen?
Yeah, it's identical to mine.
Oh. Demerit.
Upgrade. I have to write small.
I know, it's very tiny.
0.5 aren't so bad. 0.38 is miserable. They're not bad. If you like write really, really tight, they're okay.
Impressed with myself.
Very nice. You should be.
So
Very
1 mil, they leak everywhere.
think you are.
Yeah.
When I show up with a F-35 tomorrow. You're like, what? Yeah, Barb's gonna laminate them and then. Corbin.
So we'll probably get those around the same time we'll get our,
Barb is much more efficient than the uniform lady. And Elijah.
How does it open?
Oh yeah, you had your extra.
You know when you're on the Moodle dashboard and you look at the labs, is there an easy way to know which ones were handed out in paper and which ones are digital?
I don't know if it is on yours or not. Mine show, circle thing, the little one, paper thing, paper one.
I think mine
Okay.
should
Stephen. Oh, thank you.
Yep, too fast.
It's really clean. John. There is Anthony.
He stepped out for a little bit.
Okay. Well, I mean, if he doesn't want to use the,
Not as nice as like
Daniel.
Neuros.
Oh.
So here to enter these fractions, it's 4 places, so it would be a 1 followed by 4 zeros, and it would be a 10 followed by 4 zeros.
It would be
some pins, rubber grips,
one
sticky and
followed
nasty,
by
sweaty.
4 zeros, because it would be, yeah, 10,000. Yes.
Right.
Just make it. Thank you.
And
If I can find this pin,
Samuel.
this will be my go-to.
That's kind of a rhetorical
Oh.
question, it can't
And
really.
you can,
See if Walmart all speak.
let's see.
Oh.
20